Well, graph databases in general start with basic structure of nodes and nodes and relationships. Nodes are represented by a circle in a graphical world where these nodes represent things. I've taken an example of a movie database. We have taken Toy Story as movie. Then we represent these nodes by one or more labels. So we have given a movie label, we have given animated as another label. They also hold data in the form of properties called as key value pairs. Like I've given this particular movie a title as Toy Story, released as 1995. So this is the starting point of graph databases. Uh, if you recall the graph structure in your undergrad days, where you ever heard about graph theory, that's what graph DBs are essentially about. Well, the nodes are connected, the two nodes are explicitly connected via something called as relationships. We also call them as, so we add a relationship type, like Tom Hanks is an actor, one node, other actor is movie. The relationship between the two called as acted in relationship. They also hold data in the form of properties like key value pairs, roles is Woody. So Tom Hanks acted in Toy Story with the role as Woody. Okay, for those of you who want to understand how it maps from a relational to a graph world, I'm sure this slide is going to be really helpful to understand how the mapping looks like. While we always encourage to think in a graph sense, graph modeling sense, but you can use this as a reference point and then maybe do a migration or start with this diagram and then build your graph structure. So your rows are basically rows in your relational database maps to your nodes. Your joins maps to your relationships. Your table names maps to your labels, and then your columns maps to your properties. Um, Pretty easy, pretty good to work with. I'll show you the next slide, which will talk about the performance and might clear some myth that graph DBs are not great. But wait 1 second. Just before that, we built not just a database, but rather a data platform, graph data platform, which has a database, native graph database. It also has data science and analytics capabilities. And we also added more development tools and frameworks. We built in integrations with Kafka connectors, Spark, like any of your data pipelines, any of the tools, any of your libraries, Spring, GraphQL. We started building all of those. We started off as a Java library, as a jar file, and then we built on the integrations with the other tools and frameworks. Not just the data science and database, we also built something for discovery and visualization called Bloom, which will help you like do it, look at your data in a 3D representation way. And then we also built in the support for GraphQuery language. Anyone heard of GraphQuery language? No? Okay, cool. Just to give you a quick intro, ISO launched GraphQuery language as a standard language for all the graph databases out there. It's the first language in the last 40 years which ISO has invested in, and graph databases sooner or later everyone gonna shift to GraphQuery language as a standard language instead of each of them having their own proprietary language. Just like your relational databases have structured query language, similarly all your graph databases are gonna have GraphQuery language. So best part about GraphQuery language and our Cypher, which is a proprietary language to use on GraphDB on Neo4j, is Cypher is already compliant with GraphQuery language. We have contributed a lot to the development of GraphQuery language. So today you learn Cypher. Tomorrow, once everyone and ourselves migrate to GraphQuery language, it's going to be an easier learning curve for you. As I said, ecosystems and integrations with BI tools, Kafka, Spark, all of them are there. And yes, it runs anywhere. If you have worked on Neo4j maybe 5 years, 10 years ago, you might not know this, but we have something called as cloud offerings as well, where you can run it as a database as a service on cloud. You can also use the cloud managed services, not just the desktop version, but we have these two additional offerings. So yes, so you have the self-hosted version, which is running on-prem. You can just download as a desktop file or put it on a Docker container. You can go via the cloud managed services, anything from AWS, Google Cloud, or Azure, and then run it via them. Or you can use our database as a service, which also comes with a free tier. Good for POCs, good for initial prototyping. And then you can switch to a professional edition. Yes, this is a slide which I was talking about on the performance part. Now, give you a good comparison between a relational versus a graph world. Like how this is a little older slide, like quite an older slide, but I'm sure we have done much, much better than this, in fact. So if you have probably 800,000 records and you're going for the fifth step, your relational database query might not execute at all or finishes the execution versus a Neo4j can get finished in the same data, the same query gets finished in 2 seconds, roughly around 2 seconds. Some misconceptions around GraphDB. I'm not building a social media. A lot of people think that Facebook has built a social graph, LinkedIn is there having some social graph kind of thing. They're good for social media kind of use cases. But it is yes, social media recommendations are great use case for graph, but not just all. Do you see any of the companies here working in social media or have there any social media platforms? No, right? But all of them have graph or they use graph in one of their applications. It could be internal or it could be external applications, public facing applications. The next misconception is that it cannot be used as a primary database. Well, that's also not true. Graph databases are capable to store the data permanently. You can use it as your single database as well. So Neo4j has a built-in this storage. So you can put your data into so your actual data pipeline you can get rid of your actual data pipeline and just move everything directly to Neo4j. Another misconception is that it's okay, it's good, it's perfect, but it's not easy to learn, it's not easy to understand. We are building the best in the world courses, content around graphs called Graph Academy. So you have to just go to Graph Academy, take these self-paced courses all the way from graph fundamentals, Neo4j fundamentals, to advanced Neo4j techniques, graph modeling technique, to also GenAI content. So we're building and coming up with new contents every now and then. So these are also self-paced. These are also kind of like a workshop kind of a format. So you can go with a step-by-step format and then get yourself upskilled. We also have 2 certifications that you can test your knowledge on. So do take those certifications. Okay, it's not easy to set up and get started. Well, your answer is Aura DB, which I mentioned earlier. You can just use it on cloud. No installation, no setup needed. Just directly go to the Aura DB page and quickly get started on it. We give you 200,000 nodes and 400,000 relationships to start off with as a free POC, lifetime free, so need not to worry. As long as your work can be done within this, you're good for the prototyping stage. Okay. These are some organizations that are using Neo4j in multiple industry verticals, banking, technology, telecommunication. Again, not just restricted to them, but these are the few major verticals that we feel are really important. Neo4j is also a GenAI enabler. We're going to talk about how you use Neo4j and GenAI together. Karan is going to give a talk towards the end on this part. You've seen some early breakthroughs on in real-world use cases. Unfortunately, we can't quote these customers, but there's an oil and gas customer, there's an automobile customer, there's one supply chain industry, there's one in the customer domain, D2C domain. So all of them have used Neo4j and GenAI in production to build applications at scale.
If you're serious about a career in AI, follow Deep Tech Stars on your favorite social media platforms.